Hi everyone. So I know that it's kind of loud in the background. I'm in the airport and Alexa just texted me or emailed me with the questions that came up in class today. So I'm going to go over them quickly. So the first one she mentioned was page 13 in your review packet, number 14. Which cubic function is graphed? So let me remind you that polynomials can be given to you in standard form, which would look like this, like so f of x equals, I don't know, x cubed minus 2x squared plus 5, or factored form. Factored form look just like all of these answers. So f of x, where they give you the factors, like x plus 3 squared, x minus 1. So the first thing I want to be able to do is determine the degree. And I determine the degree if it's in factored form by adding the exponents. So all of these have exponents of 1, so they are, and it says it's cubic. So it's a degree 3 polynomial. Then I want to look and determine if the leading coefficient is positive or negative. All right, so positive, because all of these, if I multiply them, are going to give me positive numbers. This one's negative, and I think that's the only negative. So I look at this, the end behavior is down, up. Down, up, cubic odd degree polynomial tells me that it's going to be a positive leading coefficient. So I can eliminate B. All right, then I looked at the zeros. So I had to notice that the units here, that each index was 2, so the scale is different. So that's telling me that this is a 0 of -2, this is a 0 of -1, and this is a 0 of 4. So if these are the zeros, remember we write the factors opposite. So x plus 2, x plus 1, and x minus 4. So I'm looking for a polynomial with those zeros. Now the good news is, because they all have a degree 1, that means that the multiplicity is 1, which means it goes through it. It goes through the point. So I'm looking for x plus 2. So I see I'm going to get rid of this one. So there's an x plus 2. I'm also looking for an x plus 1. So I'm going to get rid of this one. I can keep, here's an x plus 1, an x plus 2, an x plus 1, an x plus 2. But then I'm looking for x minus 4, which would be this one. So my answer would be C. The 1/3 in this case didn't really matter to me, but remember, the A term always makes it either narrower or wider than the parent graph. All right, section 3. Now, I don't love the question. I'm sorry, I should have taken it off, but I do like the concept. Batman throws a batarang high into the air so that its motion is modeled by the function. Now, it is a quadratic function, so I need to know if I'm throwing something up into the air, that we've got going up in the air, and eventually hitting the ground. I know that it's an upside down parabola because it's negative in front of the function. I know that the y-intercept is 616, so that means that's the initial height of the ball. But it's asking, what is the highest height the batarang will ever reach, and at what time does this occur? As a reminder, you should always write these equations as a time-height model, marking your axis. Don't try and do these without a picture. So when it's asking at what time will it be at its highest height, it's asking for the vertex. So time is x, height is y, and to find the vertex in standard form, we do x equals -b over 2a. So in this case, we're going to do -142 all over -32, because 2 times -16. And I believe that works out to be approximately 4.4. So that's seconds, 4.4 seconds. So I know that it's going to be at its max at 4.4 seconds. So now I need to find that actual maximum height. How do I do that? I plug the point in. So -16 times 4.4 squared plus 142 times 4.4 and plus 6.16. All right, so you're going to try and do all of that. I don't have my calculator, so I'm going to try and grab my phone since I'm sitting in the airport. Okay, so we need to do, let me get my calculator. So we need to do 4.4 squared times negative 16 gives me negative 309.76 plus. Then I'm going to do 142 times 4.4, which gives me 624.8 plus 6.16. I'm going to add all those together, and I get approximately 321.2. So that means the Batarang is going to reach its highest height of 321.2 feet in 4.4 seconds. Okay. The next one asks me to use a graphing calculator or the quadratic formula. I want you to use the quadratic formula to find when the Batarang will hit the ground. Remember, when we hit the ground, we're looking for the x-intercept. So we are setting the equation equal to 0, because that's what the height would be. The height would be 0. And we're solving by using the quadratic formula. So I do not have my calculator here. I want you to try to use the quadratic formula on that one. And the answer is online. Now, number 3, I forgot to mention, I want you to skip it. We're going to go back to that one. This one doesn't work out so pretty. So, but you should be able to solve this equation using the quadratic formula. All right. The last one. A 3-mile cab ride costs $7.90 and a 9-mile cab ride costs $18.70. Find a linear equation that models the relationship between the cost and the distance. So we have to ask ourselves, it's a linear model. That means we want y equals mx plus b, a linear function, okay? You should be able to look at all these and see that they are in y equals mx plus b just using different variables. We should ask ourselves, what depends on what? What depends on what? Because y always depends on x. So does the cost depend on the distance, or does the distance depend on the cost? So hopefully you're saying that the cost depends on the distance traveled. So I know that c is my y and d is my x. So now I have to turn this information, this information they gave me, into data points. So 7.90, so 3, 7.90, and then 9, 1870. So now I have 2 points. I need to find the slope, the average rate of change. I need to find it. So I'm going to do 1870 minus 790 all over 9 minus 3. So I'm going to grab my calculator, and I'm going to do 1870 minus 1870 minus 790 is 1080 divided by 6, so 180. So I know my slope is 180. Now, to be quite honest with you, that means that my answer has to be A, but I'm going to get rid of these guys. And now I'm going to write my equation. So I'm going to use point slope because I just find it to be easier. So y minus 7.9 equals 1.8 times x minus 3. So I'm going to do y minus 7.9 equals 1.8x minus 5.4. Okay, I'm going to add 7.9 to both sides to put it in y equals mx plus b. So y equals 1.8x plus 2.5. And so now I look for my model, and there it is, A. Again, guys, linear equation, slope and a point, slope and a point. All right, the last one you guys asked about, I believe, was question number 10, f of the inverse of x, and I believe you had to have found the inverse of f right here. Number 7 had asked you to find the inverse of x. So how do we do that? Well, first we rewrite it as y equals 2x minus 4 Then we flip the x and the y and solve for y. So you should have gotten x plus 4 equals 2y. Then divide by 2. And remember, I like to write it in slope-intercept form, so divide each term by 2. And there was my inverse equation. That's the inverse. Noticing that the slopes are reciprocals of each other if they're inverses. So this question is basically saying, find f at the inverse. So I'm going to do f at 1/2 x plus 2. So I'm going to plug that into the f function, which is 2x minus 4. 2 times 1/2 x plus 2 minus 4. Well, look what happens. These are undoing each other, aren't they? So look what happens. I distribute my 2, and I get x plus 4 minus 4. The 4's cancel, and so I get x. And that should make sense to you, because this is the same concept of doing g of f of x and it equaling x, and doing f of g of x and it equaling x. If this is the inverse, if I take the inverse of the function, I'm going to get what I started with, the original. So it's just some notation. Anyways, I hope that helped, guys. I'm sorry it's so loud, and I'll see you soon.